Alright, you guys, question number 6. I just made a whole video and realized like something went wrong, so I have it all written out here already. But first things first, I want you to be able to pause this and put this in your graphing calculator. I put it in my iPad graphing utility, however you want to do it, and make sure that you can graph it correctly, because you're definitely going to want to visualize this on the test, and then I'm going to go back and show you how to do it algebraically. Alright, so once you get this graph, we're going to be looking at obviously the vertical and the horizontal asymptotes. We can really see that probably my two vertical ones are going to be x equals 4 where it doesn't exist, and x equals 3 where this function doesn't exist. And there's going to be some type of horizontal asymptote in the middle here. Y equals, and I'm going to show you an easy way to figure that out. So get this up so you can look at it while we look at this algebraically. So the vertical asymptote is going to be where the function absolutely doesn't exist, right there. Okay, so I did a little sketch on this side here. And the way we know that it's going to be positive 3 and positive 4 algebraically is I just took this function and I factored it, right? X minus 4 times x minus 3 will give you x squared minus 7x plus 12 if you FOIL it. Do it, check, make sure you get it correct. I know that my denominator on a rational function cannot be 0. So x can obviously not be positive 4 where it would make it 0, and x cannot be positive 3 where it makes it 0. So therefore, my vertical asymptotes are going to take up those spaces. So x equals 4 and x equals 3. Those are my two vertical asymptotes, and that's where they came from. Okay? Now, take a look at, this is for the horizontal asymptote. This is a little trick that I don't think was in the book, so I will tell you. If the degree polynomial on the numerator, in this case it's 2, the highest exponent, and the degree on the polynomial in the denominator, alright, is also 2, is the same. It doesn't matter if it's 2, it could be 3, as long as they're equal, then the leading coefficient of the numerator and the leading coefficient of the denominator are going to become important. If you take that, the leading one on the numerator, and put that over the leading coefficient of the denominator, which in this case is 1, that's going to give you your horizontal asymptote, in this case 3. So where y equals 3, that's going to be our horizontal asymptote. If you really zoom in, you'll be able to see that that's 3 right there, that it doesn't touch. Now, something else interesting is that the vertical asymptotes, those are sacred. The function is never going to exist there. They're hardcore. They're not going to be crossed. Horizontal asymptotes are sometimes going to be crossed. They're more of a guideline. They're obviously there. You can find them. You can find them algebraically. You can find them using a graph. But it's not quite as hard and fast as the vertical asymptotes are. The other two ways to look at this, if these are not the same, let's say that it's bigger on numerator, this is, let's pretend that this is a bigger degree polynomial than the denominator. Okay, then you are not going to have a horizontal asymptote. And if it is smaller on the numerator than the denominator, then the horizontal asymptote is going to be 0. Okay, y equals 0, the x-axis. Now, that is not taking into account, that's only taking into account one rational function. Sorry, you guys, getting ahead of myself. But if you remember the practice problem we did in class where we had a rational function and then we added 2 on the end, in the side here, we realized that y equals 0, okay, was our horizontal asymptote. However, when we added 2 on the end of the function, that moved the whole function up 2, which changed the original horizontal asymptote to be y equals 2. So that's the difference there. So be careful using that trick that I just told you. If you are not just, if the rational part of the function is just part of the function, and you have other things going on auto. So be careful about that.